Here we go. What's up, everybody? Welcome back to another video from the Scalar Learning channel. And not only welcome back, but for many of you, maybe welcome. Maybe this might be your first time to the Scalar Learning YouTube channel, and you're here for a very special day. Now, what we are embarking on today is the first ever class for the digital SAT that we have launched. And actually, we're launching with an amazing partner, Dan Lerman. He's right here, and I got our Skool website up here that if you guys haven't joined yet, make sure to sign up here. Let me put it in the, can't see the URL here, but let me put it in the chat. So this is going to be our command center. This is where all your information is going to go. This is when we're going to post the schedule for when classes are, what each class is going to cover. Then after the fact, these recordings that we're presenting here are going to be, you're going to be able to find them and access them through the Skool website. We're also going to have PDFs of the slides, all that good stuff, quizzes, homeworks, everything. Now, a couple things I want to talk about. If you just kind of happened upon us today and you didn't see the promos or the other content from our email list, etc., this class is not only the first class offered from myself and Dan Lerman via the Scalar Learning YouTube channel and through Skool, SKOOL. This is not only the first class, but this is free. Okay, we talked about it for a long time, decided how to do this, how do we want to price it, how do we want to do all this. We came to two conclusions. Number one, we wanted to create the best digital SAT prep course available possible. And how does that start? It starts with the two of us, where we are both deeply, deeply invested into our crafts. Dan on the English side, me on the math side. We love what we do. We love it to death. We poured everything into this, and therefore we believe you're getting the best instructors in the world, number one. Okay? And we think that with everything we have put together in terms of our thought process, in terms of resources, in terms of all this stuff, we're going to give you the best. And we decided we wanted it to be free because we wanted to build an amazing community of people that truly value education, are going to have some self-autonomy, want to be here, want to show up, want to perform, want to extract the most value out of what we're providing. Hence, we are here. We are doing this for free. And we're going to give you the best of the best, and that's it. All right. So a lot of the resources, just to kind of give you a top-down view that you're going to want to check out, they're going to be made available based on points that you receive through the Skool platform. So it's very important that if you want to access the slides, if you want to access videos, you want to do this, that, the other, you need to participate, you need to comment, you need to chat with each other, make it fun. It's a classroom. Okay. And a lot of the good stuff is going to happen via collaboration and via communication with your fellow classmates. So that's why we are telling everybody to go to that URL. I put it in the chat, and that is that. Welcome, everybody, by the way. We got a nice group of people so far. Robert King, as always. Ishnika Azad, hey, what's up? She says hey, or he says hey in the chat. So there you go. I say hey back. And that's it. Now, just a quick overview of what you're going to see on this board. If you go to, a lot of the resources are going to eventually be up in Classroom. They're not up yet, right? That's a set of slides that I haven't made public yet, but that will be up later tonight. Here's your calendar where you're going to see all the classes, right? And if you want to see what is going on a particular day, you click on the class, and here will be the link. These are going to be customized each week to get the exact live stream URL. Right now, this just takes you straight to the Scalar Learning channel. But you see, hey, we're going to cover critical concepts. We're going to cover on this class these critical concepts for advanced math, right? And so on and so forth. And information will be here as well. Now, these are practice tests that we are asking you to complete every Saturday going forward, starting from 1. These are all official Blue Book tests going through test 6. And then after that, we're going to have different things that you're going to be asked to do after you take the practice test. Now, I'm going to show you our internal calendar just so you have an idea of the rough breakdown of what I want you guys to be looking at in terms of the assignments, okay? So, for example, today we're going over these slides, and in green are the slides. Then we're going to be giving you quizzes that we're going to ask you to complete on your own, right? That's going to be in blue. So there's going to be a quiz tomorrow, Thursday, and Friday. We're also going to have a formulas video up on the Skool website that I'm going to ask you to review. This is the math homework, by the way. And then you can take practice test 1, right? And that's your homework. You're going to have a break on Mondays. These are videos. Again, orange things are videos, but you don't have to worry about the color coding. I'm just explaining that to you. This is our internal copy. And then you're going to have links on the calendar. Oh, today I'm supposed to watch this video and that video and blah, blah, blah. So that's how it's going to go. And then next week, you see we jump into this category with these slides. We're going to have a quiz here And then we're going to have a question bank of targeted practice problems, okay? So that will be up by next week when you're ready to start digging through some of these extra practice assignments and so on and so forth. In the meantime, I want to show you guys a couple of interesting resources where you can go for extra practice problems. Obviously, we have the one at the top right here. It says SATcrashcourse.com. That is where you can get full-length practice tests, actually up to 20, okay? You use code SCALAR, all caps, for a 20% discount. And for this website, 10 of the practice tests have my video explanations for each and every math problem for all of the modules. Module 1, Module 2 on the less advanced side, Module 2 on the more advanced side. Every single one has a personalized video explanation from me, so I highly recommend it. If you're looking for some free resources, here is the SAT Question Bank, okay? It's literally satsweetquestionbank.collegeboard.org. And it's the Educator Question Bank. What you can do here is you can find questions like so. You choose SAT, you choose math, you can choose whichever of these you want, and then you're going to search. And then within here, okay, you can specify particular categories. You can specify difficulty, okay, let's say linear functions. And then you can also hit this little nifty button. And this is a button I highly recommend clicking each and every time because this excludes practice problems that currently show up from the College Board official practice tests 1 through 6. Because you don't want to be doing them here and then seeing them on the test and be like, I already did this problem. And then it kind of negates the value of seeing it fresh for the first time. All right. And last but not least, we have Math Chops, another amazing resource. Mike McGibbon is the founder of Math Chops. This is an excellent resource. And if you create an account, you can go in and self-study. You can set it to whatever score level you think you need, work on or what you're shooting for. Like, hey, I'm already in this range, or I want to be in this range, or whatever. Obviously, don't choose this if you're down here at the current time, but you can choose whatever range makes sense. You can keep a question timer on or off, and then you can choose an assortment of problems like so, and then just say, where does it say? Yeah, and then it kind of generates this quiz for you, all these different practice problems, tells you the level, so on and so forth. So this is another great place where you can get extra work in, okay? So I just wanted to start us off with that, ladies and gentlemen. And as this is a live stream, I will see your comments popping up occasionally. And by the way, Ishnika says 4:30 a.m. here in India, and super excited and zealous. Oh, awesome. What's up, Robert Gugliato? Gugliata, I hope I'm pronouncing that right. So anyways, yeah, welcome. This is the best class on the planet. See for yourself. Tell me what you think. And if your friends want to join and they haven't figured this out yet, spread the word. Let your friends know. Share the link to the Skool calendar. Everything. This is, again, Command Central, so you need to be on here in order to follow along. And by the way, if you guys do like what you see so far or throughout the video, if you like what you see, make sure to click that like button. We greatly appreciate it. It helps the channel tremendously every time you do that. So if you wouldn't mind doing that, that'd be amazing. And of course, if you haven't subscribed and you're here, make sure to click that subscribe button so you can stay up to date on everything SAT, ACT, all that good stuff. Plus, we got tons and tons of other math resources. Okay, enough about that. Let's get to it. Let's get down to business for what you came here for. All right, we're starting off with our overview. So welcome, everybody. And we're going to start with the basics. What is the digital SAT? Well, we're going to talk about everything you need to know about the digital SAT. All right? So without further ado, let's get into it. And again, if you do have questions, make sure to put them in the chat, and I will answer them as possible, okay? Do we need to memorize the unit circle? Somebody asked. I would say no. However, there are certain cases, and you're going to see in some of the questions that I pulled up today, there's some cases where it could be useful, but you don't need to memorize it. You can get away without memorizing it. I also see, just some hays and highs. What's up, everybody? What's up? Thank you so much for joining. All right, here we go. Let's talk about the history of the digital SAT. So the digital SAT, I'm not talking about the SAT. The digital SAT was announced in early 2022, shortly after the pandemic. It was officially launched in the spring of 2023, but this was just for international students. So international students have had the jump. And when we say spring of 2023, we mean March specifically. That's the first round of tests every year is in March. So that's when they started rolling it out, troubleshooting, all that good stuff. And then the College Board said the transition makes the SAT easier to take, easier to administer, and more relevant. And I can get on board with this. I think it is more relevant just from the standpoint of everything's moving to digital. And why not the SAT? It's about time. I think it makes the grading easier, a number of things easier. And it's going to create more and more flexibility as systems continue to get ironed out, where you can take it, when you can take it. I'm sure all these options will open up more so. Right now, we still have those 7 test dates per year, but it is what it is. All right. This is an adaptive test for those of you guys who don't know this, okay? The old school SAT, the paper version, was just everybody got the same test or various iterations of the test, and that's that. This is an adaptive test. So what does that mean? It means that it's a multi-stage, this is from the College Board, multi-stage adaptive test. Each section is divided into 2 equal length separated time parts, modules, module 1, module 2. And what it's really saying is depending on how well you do in module 1, you're either going to get the more difficult module 2 or the less difficult module 2. And obviously, if you're really shooting for a top-notch score, you want to get the more difficult module 2. I did an experiment. I think I got like everything in module 1 wrong for the math and got everything in the lower difficulty module 2 right. And I can't remember exactly what. I think it was like I maxed out like a 420. Okay, that's getting everything right on the second half. And everything wrong in the first half. So that tells you right there, I mean, it's not like definitive in any way, but you can see that you're clearly leveled off. Like you're not going to cross a specific threshold if you make it to the easier version. So you really want to aim for that tougher version of module 2. But this is for both the verbal and the math sections, right? So you can either go to lower difficulty or higher difficulty. They don't tell us what the threshold is, how many points or how many questions you need to get right. And I'm sure it varies from test to test. Okay. All right, now there are 2 sections, right? We have reading and writing, but within that section, we have 2 modules. Both are 27 questions and both are given 32 minutes in standard time. Then we have the math and we have 22 questions, 35 minutes each. Okay, so you can see, of course, this is shorter than the previous SAT. The other thing that's important to note is a calculator is allowed for both sections, but not only just your typical handheld calculators, which are allowed still, but the more important thing is you can now use DESMOS. And for all you students who aren't able to afford a calculator or afford a good calculator, now you have a great calculator, right? Now you have access to DESMOS. And honestly, I love DESMOS. I take the test when I'm doing this. I don't even use a different calculator. DESMOS is incredible. And that's what part of today is going to be about. It's going to be about using amazing DESMOS hacks to help you rock this SAT. All right. The total time for this test is 2 hours and 14 minutes. So you can see it's definitely shorter than the old version. And now let's talk about how it's scored, okay? So the reading and the writing and the math are still out of 800, meaning we still have a total score of 1,600. That's a perfect score. And it goes down to this idea of, once again, we're going incorrect or correct. No partial credit, right? You should answer every single question. You're not going to be penalized for getting stuff wrong. Now here's the interesting part. The difficulty level and other qualities of each question are taken into account when calculating a student's score. No points are subtracted, blah, 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 blah. But they just kind of slid that in there. The difficulty level are taken into account when calculating a student's score, okay, of each question. So what's the implication there? Certain questions are probably going to be worth more points than others. Okay, that's the implication. That's what I'm picking up, right? They didn't explicitly say that, but I think the key is to recognize that, hey, some of these tougher questions, you're going to get a little bit more of a boost as opposed to the old version where everything is sort of weighted equally. So there's something to bear in mind. Okay. And again, no points are subtracted for incorrect answers. You should not leave anything blank ever, ever, ever. Okay. And scores in the SAT mean the same thing for digital and paper-based editions. This is not so important anymore, but it is good to note, because if you do have old SAT scores from the paper version before we did the full switch this year, those are still valid, and they're meant to translate equivalently. So if for whatever reason you have a 1550 on the old version and a 1410 on the new version, I'm just making this up, that 1550 is still legit and can still be submitted, okay, if you took it before the cutoff. Man, it feels like we've been doing digital SAT for so long, and it just started like a few months ago on domestic, which is wild. It feels like we've been in digital for years. This is crazy. Okay. Moving on. And you can see here, right, just we're looking at percentiles, that 50th percentile mark is right around a 1030 or 1,000. And then once we get into the 1530s, we're in the 99th percentile all the way through, okay? So reading and writing, we've got a few different question types. We've got craft and structure. I'm going to give you examples of all of these. That's where you understand and use words in context, evaluate structure and purpose of text. We also have information and ideas. This is where you're going to be evaluating central ideas, show command of evidence from text, tables, and graphs. And we have standard English conventions, right? This is approximately 26% of the test. Edit text to conform to English convention, structure, usage, and punctuation. And last but not least, expression of ideas. Revise text to improve the effectiveness of written expression. So these are the main 4 subcategories for reading and writing. Now, if we look at craft and structure, words in context, here's an example, right? And this really just seems like a vocabulary question. Which choice completes the text with the most logical and precise word or phrase? And you can see his script was easy to learn and thus quickly achieved, blah, blah, blah. So, something use. And if you read this, because it represented the sounds of spoken Cherokee so accurately, I'm assuming it's going to say widespread use. Wait, hold on. Yeah, I mean, I'm sure it's widespread use. Let me see. Yeah, it's widespread. So anyways, what vocabulary word fits in there and gives the intended meaning, and it's widespread. Next, we have an example of information and ideas. So the following text is adapted from whatever. And Mary was an odd, determined little person. Now she had something interesting to be determined about. She was very much absorbed. Indeed, she worked and dug and pulled up weeds steadily, only becoming more pleased with the work every hour instead of tiring of it. It seemed to her like a fascinating sort of play. What's the main idea? Let's see. Mary hides in the garden. No, it doesn't sound like she's doing that. Mary's getting bored. Nope, doesn't sound like that. Mary's clearing out. I think this might be at C, or Mary feels, no, I think it's D. She feels very satisfying, because I think that's what they're saying, because she's feeling more pleased, so on and so forth. And yes, the answer is indeed D. So there you go. I legitimately forgot what the answers were here. It's been a while since I looked at these questions. Okay. Now we have standard English conventions. Now we're trying to find transitions. Oops. Sorry. I accidentally showed the answer. So each ice age is so destructive, though, that it largely erases the geological evidence of its predecessor. And we already saw the answer was hence. Hence, geologists were unable to confirm the theory of cyclical ice ages. Blah, blah, blah. So it's, again, what transition word fits there here. Hence, moreover, nevertheless, and next were other options, but they don't make as much sense. All right, last but not least, we have expression of ideas, and this is the subcategory of rhetorical synthesis. While researching a topic, students taking the following notes. Pinnipeds, which includes seals, sea lions, walruses live around the water. Okay, it says the student wants to emphasize the fossil's significance. Wow, this is a long question. Hold on. Pinnipeds are descended not from sea animals. Recently found a fossil with 4 legs. As a transitional fossil. The fossil illustrates an early stage in the evolution of pinnipeds. Okay. Let's see. Which one would make sense here? Having 4 legs, a transitional fossil. Which choice most effectively? All right. So there's a lot of stuff here about pinnipeds are descended from, not from sea animals, but were 4-legged. Okay. A fossil that resembles, it seems like B would make the most sense, because he's talking about how they're not descended from, oh no, sorry, I was wrong, C. Okay, let me look at C here. Why is this one correct? Having 4, apologize, Dan Lerman's going to be the guy doing English on Thursday, so just FYI. Having 4 legs, but the skull and teeth of a seal are rare. Fossil illustrates early stage of evolution of, okay, well, yeah, I guess that does sound a little bit better. Now that I'm rereading this. Early stage in the evolution of pinnipeds from land-dwelling ancestors. Are not descended, but from 4-legged land-dwelling carnivores. B still seems all right, but fossils to early stage. Yeah, okay. Yeah, I think this has more information that relates to the notes here in C. Okay. All right. Now moving on to my subject. Moving on to math. Okay. And somebody asked the skill stash, is this also reading? No. I'm just covering the basics of the digital SAT. Reading will be on Thursdays at the same time, 4 p.m. PST. Okay. So math, there are 37 categories broken up into 4 main categories: algebra, problem solving, data analysis, advanced math, and geometry and trigonometry. And those are the rough percentile breakdowns of, like, percentage breakdowns of how much of each is distributed on each test. All right. Somebody's asking, which websites would you recommend for reading and writing? Well, now that we have the class, I would recommend my YouTube channel right here, because again, every Thursday for the next 7 weeks, you're going to be getting an amazing, amazing verbal lesson. And again, go to our school chat, because we're going to have tons more resources up there as well if you haven't signed up yet. And that link I posted right at the beginning, skool.com. All right, so these are the main 4 categories. Here I'm mentioning math chops because that's where I got these percentages from. Okay. Now, if we look at algebra, we have the following categories. You might recognize these if you remember the old version of the SAT. Pretty similar here. Whoops. A lot of stuff about linear equations, systems of linear equations, etc. We also got some inequality stuff, and word problems are kind of thrown into the mix as well. And problem solving and data analysis, ratios, rates, and proportions, usually the most common topic on this entire test. Unit conversions, percentages. We got some scatter plots, line of best fit as well. Linear and exponential growth, probability, data inferences, and evaluating statistical claims. So a lot of good stuff like this, center spread and shape of distributions. We're going to see questions across all this material, but when we do the critical concepts for problem solving and data analysis, I'm going to explain each and every little piece of information that you're going to need to know to knock this category out. Next, we have advanced math. Now we're talking about quadratics, polynomials, nonlinear functions. That could be exponentials. It could be rational functions, solving quadratic equations, linear and quadratic systems, and obviously we have radical, rational, and absolute value equations as well. Word problems in the form of quadratics, quadratic graphs, lots of this stuff. Exponential graphs will also appear in here as well. And when I say other nonlinear graphs, again, we're talking about potentially rational graphs, okay? Once we go through the critical concepts for this category, you're going to know everything, so don't worry. Last but not least, we got geometry and trigonometry, good old-fashioned area and volume, congruence, similarity, and angle relationships. When we're talking about congruence and similarity, primarily talking about triangles, but not exclusively. Right triangle trigonometry, SOHCAHTOA, right? We're going to need to know those good old-fashioned circle theorems as well as circle equations, which is the standard form of a circle on the coordinate plane. So we're going to go over that. We say unit circle trigonometry. Somebody asked if you need to have the unit circle memorized. Again, I would say you don't. You can get away without it. But unit circle trigonometry will utilize things that if you know the unit circle, it's helpful. But there's lots of workarounds. So if that's a big stumbling block for you, don't stress. Okay. Now we have two types of question types in the math. We have multiple choice and student-produced response questions. Multiple choice are what you would think, A through D, 4 choices. Student-produced responses, you're going to type in the answer, okay? And now they can be negative. If you remember the old version of the SAT, they would always be positive. That is not the case anymore. Very important that you know that you have a reference sheet available on the SAT on both math sections. So these gives you some important volume formulas, Pythagorean Theorem, so you don't have to memorize Pythagorean Theorem, nor do you have to memorize special right triangle ratios, etc., etc. You're also going to have DESMOS, right? As I mentioned, very, very valuable tool, and we're going to talk a lot about DESMOS today. Now, an example of a multiple choice question, right? Solving linear equations and inequalities out of this category. This is one example. Which equation is the same solution? 4x plus 6 equals 18. And this is something that they love to do on this new version of the SAT. They're not asking for x, right? X is 3. They're not asking for that. They're asking for which one has the same solution, meaning for which one of these equations does x also equal 3? And that would be choice C right here. That's how you do it. Here's another example, geometry and trigonometry. This is an angle relationship question, two parallel lines. What is the value of W? And you can kind of tell that W has to be greater than 90 degrees, right? So it's pretty obviously D, even though this is not drawn to scale. But the other reason why we know that is these are corresponding angles. And when you have parallel lines, corresponding angles are equal. D is the winner. Now, here's a student-produced response, and these are the examples of good student-produced responses. You can do it in decimal format, improper fractions, and just make sure you're rounding to the nearest thousandth. But they will accept, though I wouldn't bank on this, in this case where you don't round up. I would still always round correctly, whatever way you need to do, up or down, depending on the numbers. And notice here, right, you can have negatives, okay? Yeah, that's it. All right. Now you notice here, right, they didn't go to the thousandth. That's a problem. Unacceptable. Didn't go to the thousandth. So if you're rounding, it's a problem. Oh, wait, let me actually go back so you can read this. Obviously, only one correct answer, 5 characters for positive, and up to 6 for a negative, because the negative sign won't count as a character. We already know that, right? If it's a fraction, enter as the decimal equivalent. Round to the 4th digit. Mixed number entered as an improper or a decimal. And that's it. No percent symbols, commas, or dollar signs. Okay. All right, here's another example. Problem solving and data analysis. What is the mean? So what would you do in this case? Add all these up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whatever they add up to, divide by 10, and we get 9. And you just enter it as 9. That's how you do it. Okay, another example. 13 is P percent of 25. What is the value of P? So the question is, 13 is what percent of 25? You can do that in your calculator, but it should be 52%, just over 50%. So 52 is what you answer. Don't enter a percentage symbol, and you're done. Why should you take the DSAT, digital SAT? All right. Well, obviously, it's a major admissions criteria by many universities, and it can also give you amazing scholarship opportunities. And momentum is shifting in the direction of colleges, once again, using standardized tests for admissions. We see this at MIT, at Brown, lots of schools, other schools in California now shifting as well. So the writing's on the wall. It's only a matter of time until it's going to become mandatory. But even while it's not mandatory, I would take advantage of it. It's another differentiator. And it's a test that you can master. So I don't want you to be in the mindset of, well, I'm just not a good test taker, so this is my hall pass. I can get out of this. I don't have to take it. Because a lot of people are taking that avenue. So you can be one of the people that is not taking that shortcut and instead using this as another positive element of your application. And look, we're doing this all for free, so you're not even going to have to pay for it. It's just a matter of putting in the time, putting in the work, putting in the effort, do your thing, okay? So take the chance. What else are you going to do? I mean, unless you have something else really important that you want to work on this summer, fine. But take advantage of it. You can get money for scholarships, and you can obviously help yourself stand out. So highly recommend it. Okay. Now, these are just some examples of scholarships, okay? Texas State University provides the President's Honor Scholarship, $48,000. And you qualify with a minimum of a 1420 SAT score. Okay, you also have to be a top in your class. But then there's also the Texas State Achievement Scholarship. I mean, this is a lot of money. And if you don't take the SAT, you can't qualify. All right, Tuskegee University, look at this. Full tuition. That's over $100,000, maybe close to $200,000. That's crazy. Okay, and to qualify, again, you need an SAT score between 1,300 and 1,420. University of Alabama, Huntsville. Again, this is just a small sampling of different universities. You can get, again, full tuition and housing. That's insane. You don't pay for college. Okay, now 1,600 on the SAT is rare, but it's pretty wild. University of Arizona, you can get up to 12,500. And non-resident Arizona awards, up to 32,000. Again, breaking a 1,420. Okay. For admissions, okay, we can see where what we're aiming for to try and be in the mix at these universities. Obviously, again, hey, fine, if it's optional, you don't have to submit it, but that's going to hurt you. They want to see a score if you have a good one. And again, here we go, Princeton University, we're talking 25th to 75th percentiles and 1,500 to 1,580. Now, that's basically the middle half of students that get into Princeton. That's what they're scoring. If you're looking at Michigan, my alma mater, right, we're talking 1,350 to a 1,530. Somewhere in that zone, you're competitive. And this gives you a great baseline of like what you should be shooting for if you want to go to this school or that school or whatever. University of Georgia, we're aiming for 1,220 to a 1,420. University of Arizona, 1,140 to a 1,370. Okay. Now we're going a little bit lower in the rankings, 142. Now we're talking about an 1,130 to a 1,380. And I think this is the last one I have in the presentation, 1,030 to a 1,240, University of Wyoming. Okay. So you can use your digital SAT score as a good barometer of like, all right, these are the schools that are probably within a realm of possibility to get into. These ones may be a little bit of a tougher reach, et cetera, et cetera. All right. The skill stash says, I wouldn't say it's a stumbling block. I can definitely remember it. Just wanted to ask before I start studying. All right. So asking about the unit circle. Yeah, no worries. We totally get it. Okay. Oh, I have a couple more examples. Clark University ranked 280th. See, we now have a much lower threshold for the SAT. You can get as low as 890 and still be in that middle range. And William Carey University, 980 to a 1320. All right, so just to give you some perspective. How do we register for the DSAT? go to College Board. You can even Google it and just say, hey, how do I register for the digital SAT? But it'll take you here. Log in. You should have an account already created through your school when you took the PSAT. If you don't, reach out to somebody at customer service at the College Board or ask your principal. Get signed up, register, so on and so forth. How to study for the digital SAT. You need to get the Blue Book app. Not only you need to get this to study and to access the 6 available practice tests, but you need this to take the SAT because you're going to bring your device on test day. Log into your Blue Book app and take it that way. Another great place is Khan Academy, right? You've got amazing free resources there as well. We've got some other places as well for paid resources. Obviously, the two at the beginning that I mentioned, the College Board Question Bank, as well as Math Chops are 2 great resources. Oh, and of course we have SAT Crash Course, right here. You can see the link up there. That's the one that's my favorite. I'm going to mention again here as well. But we've got Princeton Review, Digital SAT Test Prep. We got Test Innovators, not a bad resource as well for additional practice tests. Score Smart's another one, and this is the SAT Crash Course. This is the one that I'm a part of. That's the one that obviously I think is the best. They also have my video explanations up there, so check that out if you want to purchase tests piecemeal or a bundle of 10, whatever your needs may be. All right, when is it offered? Again, 7 times per year. We've got March, May, June, August. By the way, this class will team you guys up to take the August SAT, so that's what will conclude that week before. October, November, and December. Just a fun fact, if you're applying early, October is usually the last time you can take this and still submit that for early admissions. November and December are later test dates, but obviously if you're going regular admissions, you still have those to take it once again. What is the best test date? I get this question all the time, okay? So what is the best test date? It depends on when you're ready. Now, I want to make this point clear. I've heard people in the past, people don't say it's too much anymore. I think this myth has been dispelled, but I heard like college admissions counselors say this, and it was just totally wrong. It's not like August, it's a better curve. There's no curve on the SAT, okay? The scoring is done by a process called equating. It has to do with the perceived difficulty of the test, not how other people do on the test. So you don't get an advantage de facto from taking it in August or October or this time or that time because the competition's lower, higher, whatever. It's not about that. So you are going to take this test date when you are ready, when you've done the preparation, when you've done the work. August, I think, is a great one. And then if August is not satisfactory, you got October right around the corner. Plus, you have the entire summer to study. So that's my recommendation. Now, the College Board recommends to take this thing at least twice, okay? I would say that's fine. I think you can take it 3 times, and you don't get penalized. What's happening is the majority, well, I should say that some schools will ask to see all your scores, but it's a minority of schools. I'm going to talk about that in a second. But do I think they're really going to get so angry if you take it 3 times, they're going to penalize you, or even 4 times or something like that? I don't think that's the case. They will see everything. And I still think if you have more that you can show that you can do better and better and better, I would recommend taking it again. Big deal. Especially if it's a school that, like most schools, are super scoring, right? We're going to talk about super scoring in a second. But take it multiple times. I just wouldn't use one of your attempts as like, hey, this is just a test run. I'm not going to study. Don't do that. You have practice tests to do that. So make sure you go and you prepare every time correctly. Okay, now we're going to talk about how colleges work when you submit multiple scores. They're either going to take your highest score only, across the bat, like talking about overall highest score. Superscore, which is what most do, they take your highest sections across all attempts. So all they're going to see is you got an 800 in math on this test day, you got an 800 in verbal on this one, you got a 1600, done, you're out. And then we have all SAT scores. Again, we don't know if they're averaging, we don't know what they're doing. My assumption is a lot of those might average. Why else would they ask for them all? And here's the list, right? If you want to see who does what, this is where you can find this PDF here. Obviously, it's a long link to copy down. Maybe you can take a quick shot of that link. But, yeah, you could also just Google, hey, superscoring, what school superscore, et cetera. It should take you to this PDF. But that's how you can see where your school lands there. But no matter what, I would definitely plan to take it at least twice. I mean, that's what the College Board is saying, so. Okay. Now, moving on. How much does it cost to take the digital SAT? Here's the cost. The main registration cost is $60. If you need to change your test center, $25. And you can see a bunch of these are $25 canceling fee, late canceling fee. Late registration, that's easy to avoid. Just don't register late. You don't have to pay that $30. Now, the score reports are no longer the detailed scores where they also give you every test question and all that. That's done for the time being, sadly. It's very unfortunate. So I just want you to know that when you get the score report, it's not going to be the old QAS service where you're getting, hey, my question answered. This is no longer an option. All right, but here are the various prices. Now, what should you bring to the digital SAT? Your testing device, as I mentioned, right, wherever you have the Blue Book app. These are the different possibilities. A charging cable, a backup testing device, just to be safe. Face covering if required. I mean, I haven't seen a place require face covering in a very long time, but check. Your admissions ticket, your photo ID, pencil and pen for scratch work, handheld pencil sharpener. Now, you're going to get scratch paper at the digital SAT. They're going to give it to you, and I think they give it to you one sheet at a time or two sheets at a time, but then if you need additional, you're going to have to just raise your hand and they'll swap it out with you. Bring in an acceptable calculator. I think that I have the list in this presentation, but I would say Desmos is your go-to. And if you do bring a calculator, bring extra batteries. Healthy snack, silent watch, okay? Healthy snack, I've talked about this many times on my channel. You know what I mean. Good protein, good fats. Avoid those sugary things and just junk food. Carrots are good. I think good quality string cheese can be good. Some cold cuts. Almonds, you know, you can get a banana if you need to. Just make sure you don't want to spike your blood sugar. That's the idea. Caffeine only if you're already drinking caffeine on a regular basis. Otherwise, I would say no. Water, stay hydrated. And of course, your bag and your backpack, right? Whatever you're bringing your stuff in. Okay. If you need an epinephrine shot, right? If you have a high allergy and you're potentially in danger of having a severe allergic reaction, then you can bring that as well. Those are allowed. Now, if you want to see the College Board approved calculators, here's the list. I'm not going to go over all these in detail, but these are Casio, Hewlett-Packard, Radio Shack. We've also got a bunch here. Sharp, other, and Texas Instruments, the most popular ones, right? But you can see TI-84 Plus, that's probably a really common one in math classes. So if you do have one, you can bring it. But again, I highly encourage you to check out Desmos. It is amazing. Okay. Good luck, everybody. That brings us to the end of the first presentation of today. Do they accept power bank? Somebody's asking. I don't know what power bank is. If that is a calculator, it's not on the list. So I don't think so. But I'm not sure what you mean. If you could clarify. All right. Moving on to the Desmos portion. Okay. So today on this presentation right here, we're going to do some Desmos hacks. And what I've done is, if you're not familiar with Desmos, I'm going to show you pretty much how you can utilize it and navigate. And the beauty of it is it's very simple. So because it's simple to use, you're going to love it. And I'm going to show you how to do a ton of these problems by literally choosing sample problems, just being like, all right, this is how you're going to use Desmos to solve it without anything else. Okay? So make sure you're paying attention. This is very important. Now, let's take this question. Solving linear equations and inequalities. 4x plus 6 equals 18. Watch this. I'm literally going to take that equation and just type it in. Now, you see this weird line thing. Where is the line occurring? At 3, x equals 3. What is that telling me? That my solution for this is x equals 3. Okay, so which one of these has an answer where x also equals 3? It's C. 4 times 3 is 12. But if you couldn't figure that out, you can still use Desmos even more. Watch this. 4x equals 108. That gives me a different line over here. Incorrect. 4x equals 24. That gives me a line at 6, not 3. I'm trying to get the same solution. 4x equals 3. That's option D. Again, different. But then 4x equals 12. Boom. Right on top of the red line. Boom. Done. Okay. Next, what is the solution to the given equation? Once again, type it in as is. 4x plus 5 equals 165. There's my answer at 40. 40 is the winner. Boom, done. Function is defined here. What is the value of f of x when x equals 4? Watch how I'm going to solve this one. I'm going to show you how to do this one. You could even type it in as f of x equals or y equals. Both of this give you the same result. We got that nice graph. I want to know what is the function value or y value when x equals 4. Look how I typed it in. Oh, look at that. Now it gives me this beautiful intersection. So when x equals 4, the function value is 30. That's how you do it. Boom, done. Another one. Now I'm going to show you two ways to do this. First, 9x minus 10y equals 19. There's my linear equation. It's translated down by 4 units. What is the x coordinate of the x-intercept of the resulting graph? Okay. So if this is, actually, wait, let's do like this, negative 1.9. So do we have a slope value? Yeah, it's all decimals here. Okay. I'm trying to think of the best way to show you how to do this quickly. All right, I'm going to go old school, okay? So when we have a translation down, actually, no. First, I'm gonna put this into slope-intercept form. Then I'm going to show you kind of like the traditional translation method. So if you want to put this into slope-intercept form very quickly, negative 10y, I'm going to sort of do the work on here. I'm not going to write it out, equals negative 9x plus 19. Then we're going to divide both sides by negative 10. Y equals positive 9 over 10x, right? Minus 19. Oops, 19 over 10. All right, so I just put it in slope-intercept form. You can see it's the same line. So we're good there. Now, the reason why this is nice when we're talking about translating it down by 4 units is once I have it in slope-intercept form, I just go minus 4, boop, it's down. And what's my x-coordinate of the x-intercept? It's right there, 6.556. Now, this is obviously, I think it's 6.5 repeating, which is 6 5/9. But another way that we could do this is if you take your original equation, and you're going to see that this is going to overlap now. And if I ever want to shift down by 4, down by anything, it's y plus whatever that value is. So if I did y plus 1 and shift down by 1, 2, 3, and 4. So that's another way if you want to just plot it right here. And then again, we can get this x coordinate of 6.556. Now, you can enter it as is. Again, as I mentioned before, for the free response, it will take it rounded to the nearest thousandth. Or you could also enter it as the improper fraction. But I would just do rounded in this case. Okay. Next, we're trying to figure out which equation could represent this linear equation. Again, if you're not sure, what I see is I see it intersecting at 40 and 60. And all I got to do is just plug in these different equations and see which one hits that. Now, I can pretty quickly dismiss A and C because those have y-intercepts of 8 and 12. It's not going to be correct. Okay? Let's try B and D. 8x plus 12y equals 480. And 12x plus 8y equals 480. All right. So we're looking for a y-intercept of 40, right? And an x-intercept of 60. And that definitely looks like the purple line. Purple line is 8x plus 12y, which is B. That's how you do it. Boom, done. Not written down anything yet. Strictly using Desmos so far. So it's pretty powerful. Okay, here we go. The solution to the given system of equations is x, y. What is the value of x? All right, so when you have a system, the way to use Desmos, literally, I mean, it's so beautiful. Just plug it in. Watch. We plug it in, and what's the solution to a system? It's where they intersect, right? Boom, it gives you that intersection point. It's drawing you to it. What is the value of x? It's 15. 15 is the winner. Boom, done. And you can see for both of them, 15 will give you negative 45 for y. There we go. Whoops. Now we have another system. All right. Now this one is very interesting. Okay. Because they've made it complicated. They didn't just give us, hey, what's the solution, right? They gave it to us with this r value, which is a constant. Okay. So here's what I'm going to do first. I'm going to enter in these two equations. Okay, there's one. Well, look at that. It's the same line. I entered both of these, and it's the same line, meaning we have infinite solutions, okay? Meaning these are the same lines. That's it. Okay. Now, again, without using anything other than Desmos, we're going to try each of these options. So let me show you something. First, we're going to do r over 5. I'm literally typing it in just as is. R over 5 plus 7. Negative r over 5 plus 35. Okay, hold on. Actually, I'm going to type in all the answers so you can see in real time which one works. And we're going to add a slider for r. Actually, let's add it now. Okay, we're going to come back to that. So let's do option B. Let's see, negative 3r over 2, comma, 7. Oh, plus 7 over 2, sorry. Plus 7 over 2, comma, r. Okay. Well, I guess we already know the answer is that point. But just give me a second here. Because I want to be able to explain how this works exactly. 2r over 3 plus 7/3. That's in green. You can see that's not on the line. And then we have r, comma, negative 3r over 2 plus 7 over 2. Okay. And that's purple. Wait, does that also look like it's on? No, purple's on the line. The only thing that's on the line is the blue one. Now, what did I just do, right? It said that r can be any real number. So that's why I added a slider. And right now, r is equal to 1. But the point is, anywhere that I move r, the correct value should still be the correct value, meaning it should still be on this purple line. So as I move it up and down, you notice the blue dot, everything else is moving all around in crazy options. I can even find a value where, hey, purple and green look like they might be on the line. But look at blue. It's always there. And that immediately tells me my answer has to be B. That's it. And that's how you do it with the slider. Okay, you don't just have to slide to, you can also type it in manually and so on. Okay. All right, we got an inequality. I'm going to show you how to do a system of inequalities. Check it out. Again, I'm not doing anything crazy here. They're saying we got a system of inequalities. Cool. Let me just enter those inequalities. Okay, great. And it says the point x53 is a solution. Instead of doing x53, I'm going to use a53. Okay? Because now I can add a slider and they want explicit values. They want it, they're asking, is -9 an option for x? I don't know. Let's see. Oh, look at that. Wait, is that in the right solution set? Okay, hold on. Let me explain the inequality first. So the gray portion is the solution for the top one. The red portion is the solution for the bottom one. And then the dark red is the intersection of the two. So whatever our correct solution should be in that region, the first one is -9 works. But we can see with the rest of them, -5. Nope, it's just in the gray. That's wrong. +5, way wrong. And +9, even worse, right? So you can, again, quickly see with Desmos, as long as you understand what the double shading means. This is our solution set. What is 10% of 470? Again, you're going to need to know. Actually, I want to try something. Let me do this. Oh, my God. I actually had tried this before. It's as simple as that. What's 10% of 470? Right, 10% of 470. Okay, the traditional way to do that is 10% as a decimal is 0.1 times 470, right? It's 47, but this is even better. Literally just writing it in. So that's beautiful. We also have this one. Okay, I got to try something here. A is 110%. Let's see if I can do 110%. It's going to say of. I don't want of. I want greater. Yeah, that's not going to work. Okay, anyways. So we want to convert this to an equation, right? And when I see the word is, I'm thinking equal sign. So A is 110%, but in decimal form at 1.1, greater than the number B. So if I do that times B plus B, okay, now we have a legitimate equation because that's 110% greater. If I said 110% of B, then it'd just be 1.1 times B. And 1.1 times B plus B is 2.1B. Oh, yeah, and shoot, it's giving me an equation, treating these like variables. Hold on. Let me see if I can fix that. Why is it doing that? 90% less than B is 90% less than 47, which is 10%. Okay. Well, it's not letting me do a slider here. So this is a little bit of a problem. But here, we can still use Desmos without writing anything down. So then it says B is 90% less than 47. Okay? So 90% less or 30% less or whatever, we're taking 90% of 47 and subtracting it, meaning we're retaining 10%. So B is equal to 10% of, or 0.1 times 47. So now I know that B is 4.7, and look at this. We already have our equation here. It's taken that B value, and it's like, oh, B of 4.7 goes in here, 2.1 times 4.7, 9.87, and we got it. Again, before I put this in, you see it sort of interpreted them as X and Y, which I didn't anticipate until you do the second part that was going to do that, but there you go. All right. Next. What is the median of the data shown? Obviously, you should know what median is and all that, but if you don't, look at this. Median of 73, 74, just put it in as is. 73, 74, 75, 77, 79, 82, 84, 85, and 91. Boom, spits out your answer. Now I can show you why this is also correct. The median is the middle value. 79 is in the middle, 79, and it has to be in the correct order, right? But in here, you don't have to enter it in the correct order. Like, watch. If I move 79 and put it at the end, that's the beauty of the median function. It still gives me the right answer. And also, what about when they ask for the mean? Guess what? Mean function 6, 8, 16, 4, 17, 26, 8, 5, 5, 5. As long as you don't make any typos, it spits it out for you. Mean, obviously, you add them up and divide by 10 in this case because there's 10 values, but you don't even need to know that. DESMOS hack. What's up? All right, next. 11. Which of the following equations is the most appropriate linear model for the scatter plot? So what do we do here? Well, they're giving you all these beautiful equations that are meant to be the line of best fit, really, right? That's what they're saying, appropriate linear model. Let's start plugging in. Let's see the top one. Negative 1.9x minus 10.1. And we got to zoom in to get kind of equivalent zooms, right? And you can see really, what are we looking at? We're looking at from 10 to 10 in that little window. There's nothing here. Why is this over here? Clearly wrong. Let's try option B. Well, look at that. That looks pretty accurate, right? About a y-intercept of 10. We've got about an x-intercept of 5.3. That looks about accurate. I think this is the winner. Now, I'll quickly show you option C so you can see how wrong it is. Or option D, how about? Positive slope. Why do we have a positive slope? We should have a negative slope. So you get what I'm saying. You can just plug in the answers and figure it out very quickly. Yes, you can use digital map CS. Can we use digital Desmos on digital SAT? Yes, the entire thing. You can use Desmos for the whole thing. It's beautiful. It's amazing. Kind of insane, actually. Okay. Another line of best fit. Again, same idea. Which one is this? And again, get that window kind of equivalent, right? We're going from 14 to 14 or whatever. I know it's a negative slope, so it's got to be either B or D. That narrows it down. And, well, it's got to, actually, it is going to be B, but watch this. I'm going to put in B. Pretend I didn't know. And look, then just measure it up. Oh, wow. Y-intercept of around 13.5. That looks accurate. X-intercept of around 16.875. That looks like that's where it would be going. I feel pretty good about it. Everything else is going to be way different. Which expression is equivalent to this? Sure, if you know your exponent rules, you can rock out with this one. Or just put it in as is. Now they said add a slider for A. Yeah, we should add a slider. Just don't do 1 or 0. But you want to do 2, we're all good. Okay. This is what that is. Now let's see what these are. All right, here we go. And to do the index, hold on, you got to go here, and where's my radical? Okay, so you can do like 12 and then A to the 132. Okay, clearly not the same. And then we'll copy and paste. The problem is on the digital SAT, they disabled the copy and paste function. Why? I have no idea. It's ridiculous. But here I can use it, so I'm going to kind of do it like this. And if for whatever reason, there's the equivalent value. See? So I'm done. It's B. But if for whatever reason this gives you a problem and you can't do the index, you can also type this in like this. A to the 132, and then to the 144th root is the same as raising to the 1 over 144 power, like that. So there you go. You'd have plugged in these and you would see it doesn't give you the same, but that's how you do it. Boom, done. All right, number 5, same thing, equivalent expression. Okay. So what am I going to do? Using Desmos without even thinking about any exponent rules, anything else. We got this, right? Look what I'm doing here. Typed it in. Yeah, let's add sliders for each. Just don't like 1, but let's do 2. Let's say this is 3. And let's say this is 4. Now, I'm not saying this is the fastest way to do it. Probably the fastest way is to just multiply and use our exponent rules. Again, I'm just giving you a backup solution in case you forget your exponent rules for whatever reason you're unfamiliar. This is ways that you can use Desmos to get there. L Flash is asking if I can do a problem about 2 solids stuck. I know exactly what problem you're talking about. I'm probably not going to be able to do that particularly today, and that's going to be part of the thing with this class is I'm going to answer quick questions in the chat, but for the longer ones, we might be creating an additional office hour space where you can come in and ask me to go over specific questions. That we're going to talk about at a later time because that's gonna be kind of like a different process. But anyways, so hold on to that question, and at some point, once those office hours are available, we're going to get to that. Okay, anyways. So again, we've got these different values in here. Now, all I got to do is see what does this equal? Oh, it equals this weird number. Fine. Not my favorite, but as long as we can get one of these to spit out the same value, we're done. So let's try the first one. M to the 4th, Q to the 20th, Z to Z negative 3rd. Nope, that's different. How about, oops, let's just do it in the same one. How about M to the 5th? I'm doing B now. Q to the 9th. And Z squared. Ooh, look at that. Matches on the dot. We're done. B is the winner. Now, I'll explain with exponent rules. You add the exponents when you multiply. 1 and 4 make 5. 4 and 5 make 9 for Q. And negative 1 plus 3 is 2. Boom, done. We have another equivalent expression. Okay, so how am I going to enter this with Desmos? Once again, I can use X. Okay, and it'll give me a graph, but I'm going to use a constant because it's easier. I'm going to replace X with A. Minus 3 times A minus 7 divided by, divided by 2A minus 14. We're going to give a slider value. Again, 1 is okay, but I'm always scared that you're going to get false positives with 1, so let's go to 2. By the way, another thing to let you know, you want to still go through every answer choice because sometimes there could be a fluke where with A being equal to 2, you're going to get 2 hits. But then you change A to 3 and then you only get 1. So you can figure it out that way. So just if you have the time, don't go to, oh, I found a hit, I'm done, I'm out, because you could get a false positive. Okay, so now let's look at the rest of them. A minus 7 over 5. Does that also give me 6.5? No, it does not. How about 8A minus 3 over 2? It does give me 6.5. Wait, is that right? Yeah, I think that's the right answer. Here, we can check other values. You see they're exactly aligned no matter what, so you can verify. Yeah, that's 100% it. And then we can see, I don't know, let's just do one more. 8, oops. I'll do option C so you can see what it looks like again. 8A squared minus 3A minus 14 over 2A minus 14. It gives me a different answer, so there you go. The function P is defined by this. What is the value of n when P of n is equal to 56? Okay. Now, the thing about this is if I just type it in like this, right? Oh, actually, wow, never mind. I wasn't expecting it to do that. Because normally I say you have to, well, I guess it's graphing it as if it's x and y. Okay, that's interesting. So that I feel like it didn't used to do that. Now it does it. That's cool. You don't even have to read. But anyways, what I was gonna, my point was you can just quickly change this to y and x, and it's gonna work. But apparently that was good as is. And then we want to know, when does the function equal 56? Oops. Oh yeah, 56. So there I'm setting the function equal to 56. That's going to create a nice horizontal line. And we just look for the intersection point. Boom. What is the value of n or x, right? It's 2. Boom, done. Okay, for this one, it says we got a function x squared plus 9. Notice I didn't write the g of x in, but it still is giving me the graph, so that's just something to note. For what value of x is g of x or y equal to 25? It can be -4 or +4. -4 is obviously not an option. You can't have 2 correct answers in the solution, so 4 is the winner. Boom, done. Somebody is asking, will we need to know the density formula? You know, it's interesting you asked that. It is there on one of the practice test questions, and they don't give you it. So it's not in my formula review because it's very rarely tested. And it's kind of, I think most people do know it. It's just mass divided by volume. But I would say to have it in your back pocket, yeah, just in case. Just in case. A little unfair to me that they have asked before without providing it. But yeah, I would say know it. Great question. Question 22 says x is greater than 7. Which 22? This one? Ah, it does say when x is greater than 7. That condition, okay, I'll tell you why it's saying that. It's really saying that because they don't want you to set x equal to 7. Okay, they really just meant they don't, because when x is equal to 7, then we're dividing by 0, then all bets are off, right? Then you could theoretically say, I mean, it would just throw a wrench into the tires. So that's why it says x is greater than 7. It's just like a limiting factor. A lot of times you notice, like I didn't even pay attention to it because I'm so conditioned, like it sort of doesn't matter. But I'll just show you so you can see it. It'll work for all those values still. It won't change anything. That being said, you make a great observation. And I shouldn't have picked values for a that were less than 7. 2a minus 14. So let's do 8. Okay. And then we add 8a minus 3 divided by 2. So you can still see they're the same. And again, this is the problem. Like if you set them equal to 7, you get the undefined. And then you get undefined here and you get this here. But again, they're saying don't worry about 7. Anything greater than 7, they match. Okay. Next, wait, did I finish this one? Yeah, I finished it. Okay, next, this one. What is one of the solutions to the given equation? Whoops. Don't overthink it. Quadratic, z squared. Actually, I'm going to change. I like to always change it to x, even though z would probably work. X squared plus 10x minus 24 is equal to 0. And those are my two solutions. We have one at 2, the x value, and one at -12. It said you can do either. Again, negatives are legit now, so both would be good. Corey asked, will the video be loaded to the calendar? Yeah, it will be added into the classroom. It'll be in the resources section. I'll let you guys know. If you guys have questions later in the course how to access it, I'll post. Once I figure out where to post it, I'll let you guys know. 26, linear and quadratic systems. Okay. Now, this one, we have this equation, intersects y equals c at exactly 1 point. Now, very nice and straightforward. Don't have to overthink it too much. If we're using DESMOS, plug it in. And my other one is y equals c. Oh, we need a slider here. Hold on. See, sometimes I don't like when it does that. It's saying, it's like using c as a variable. So instead of getting C and adding a slider, I'm just going to plug in the values manually. So we got -41. Oops. Nope, that's hitting it twice. 2 solutions, or 2 points of intersection. -100. Nope. -319 over 4. That looks like the one. And -9 over 2. That's too high. So that's it. 319 over 4. Boom, done. Okay, moving on. All right. We have this nice absolute value problem, so check this out. Okay, we're going to type it in. We've got 4x minus 4 equals 112. And this gives us our value of x, not x minus 1. But you can see that x is either... Oh, it's not letting me click. Come on, dog. All right, well, it looks like negative 27 as we zoom in, and this one is 29. So we want the positive value. 29 minus 1 is 28. 28 is the winner. Boom, done. But again, if you want to plug it in over here, we have, what is that, 29 for x. So just to double check, 4 times 29 is 116, minus 4 is 112. It works. So that's how you do it. All right, quadratic and exponential word problems. We have a model estimates that the year from blah, 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 blah. Okay. So the number of squirrels in a population was 150% more than the number of squirrels at the end of the previous year. The model estimates that at the end of 2016, there were 180 squirrels in the population. That would be when x is 1, or t is 1. And which of the following equations represents this model? Okay. Let's see here. So here's what I'm going to do for this. And again, they have n and t. You know what's probably going to work now that I realize the other one is working. Let's just double check. Does it graph it? Yes, it does. Look at that. Okay. So a couple of things that I mentioned, right? We're plotting this, and I already said it should be going up by 150% every year. And we also know that at 1 year, meaning in 2016, we should be getting a value of 180. So let's actually set this as n equals 180. Oh, it didn't work. Okay, we're going to say y equals 180. Okay, so sometimes we need to go back to the y. So we should see an intersection point with the correct one at 180. So you can see this one's out. Didn't work. Now let's try this one, 72, 2.5. Well, look at that. We have the right intersection point. Okay. B might be the winner. Let's check these other ones. N equals 180 times 1.5 to the t. Definitely not. Right? We have the wrong point. You can clearly see if you plug in 1, you're going to get 270, I think, if you do a quick mental math. And then the other option is this, 2.5. Again, we don't have that right initial value. So that's it. We're out. Let's see if there's any other things that we can use to verify this. I think we can do a couple other points here. Look, so check this out. We have 180 here. And when x equals 2, we should get an increase of 150%. So it should be, in Skool, but there's 150% more than the previous year. So 150%. So we were at 180, or sorry, we were at 180 with the correct one. So 150% would be 180 plus 90, which is 270. So we should get 450. So when x equals 2, we should get 450. Hold on. This is 2, right? Okay. Let's see where it intersects. And there's the intersection point. Ah, it's hard to see, but yeah. See that little dot right there? And it does verify. So anyways, that's a good little trick that you can use just to make sure you got that absolutely right. Just out of curiosity, are you going to take it off of YouTube and upload to Classroom? Yes. To the Skool Classroom. We can do y equals c plus 0x. Oh, yeah. That's a great idea, Rue. You can do that. Here. Okay, so what your question was. That was for the old question, I think. But this was the suggestion here. I did not think about that. Now you can do this and you can add, if you're trying to get a constant function with a slider, you can do it like this. Just have a 0x and then plus c as opposed to just y equals c. I think that was the point. And then now, you see? Now the slider moves that horizontal line up and down. Okay. All right, moving on. Circle equations. Circle in the xy plane has a diameter with those two endpoints. An equation of this is this. What is the value of r? So here's what I'm going to do. Not going to overthink it. I'm going to type in these two coordinates. and these make up the diameter. Wait, 242. So there's the diameter, right? And all I'm going to do is just enter this. X squared equals r squared. We're going to add a slider for r. Great. And now we're going to expand it. Now, if you want to be slick here, okay, you can see that if that's the endpoint of the diameter and that's the endpoint, the diameter is 10, radius is 5. And we know that in a circle, we're equaling the radius squared, 5 squared, okay? So you know where we're going to. But even if you don't know that, watch this. We just keep it expanding, expanding, expanding. Look at that. Radius is 5, and it hits it on the money. That's how you do it. Another circle one with a little hack. Okay. We have a center. So watch what I'm doing, right? I'm just reading this, and I'm like, all right, a center at -1, 1. Let's just write that coordinate. Cool. There's my center. Line T is tangent to the circle at 0.5, -4. That means this point is on the circle. Okay. Now, I don't have the equation for the circle, but I sure do know that this, from the center to the edge, is a radius. Then it says we have a line that is tangent at this point to the circle. So what we're doing here, and this is a very hard question, by the way, okay? You obviously have to have a little knowledge, or you can't just straight up plug it into Desmos. You have to have a little bit of knowledge, which says that these 2 points form a line segment, okay? Actually, wait, we can, here, watch this. I'm going to show you how to connect these, just so you can see a little bit better. 5, -4, and then we make it a line. Bop. Okay, so there's my radius. And now we need a line tangent to this, okay? Well, a line tangent, first of all, we can use point slope. Y minus, and we're tangent to this point, y minus -4 is equal to my slope times x minus 5, okay? And for this to be tangent, it must be perpendicular with the radius. So what's the slope of this radius? Well, it looks like it's going down 1, 2, 3, 4, 5 to the right by 1, 2, 3, 4, 5, 6. So that's -5/6, which means perpendicular slope would be the opposite reciprocal, +6/5. And there we have it. Now we're looking for which one of these points is on this beautiful blue line here. Let's see. 0, 6/5. Nope. That's in that purple spot. We have 4, 7. Where's 4, 7? Right there. Nope. We have 10, 2. Looks beautiful. Right on it. And just for fun, let's go to 11, 1. And it's off. Right? So the red dot is the winner. 10, 2. Boom, done. Those are all my Desmos hacks. All right. And by the way, if you guys are still with me, massive props to you for staying committed, motivated on day one. Really appreciate it. Hope you're taking good notes and hope you're finding this useful. If you do like this video, please, please, please make sure to click that like button. We really appreciate it here. All right. Moving on to the final. And this is the Digital SAT Math Formula Bible. Without further ado, my friends, let's get into it. Oh yeah, Skillstash asked, tangent is a line that touches the circle at 1 point. It touches it at 1.1, but 2, it's parallel to the circle at that 1 point. 3, it's perpendicular to the radius at that point as well. For number 21, would you solve it with the distance formula without Desmos? No, you actually don't need the distance formula for the one that I just showed you guys, if that's what you're talking about. That circle one. All right, ladies and gentlemen, 34 essential formulas, starting with formula 0, which is a formula you don't need to know, but it's the reference sheet. These are the given formulas. So know what they are, so you know what you don't have to know, and know where they are. It's in the reference sheet right next to the Desmos button when you're in the Blue Book app. Know how to access it. You can access it any time on the math test. Just click it, boom, it shows up. So we got some great volume stuff. We've got special right triangles, Pythagorean Theorem, so on and so forth. And we also have equivalencies between radians and degrees. Degrees, 360, radians, 2 pi. Well, there you go. That means 2 pi is equal to 360. Also tells you this. Sum of the measures in degrees of angles of a triangle is 180. I bet most of you guys may know that, but important. Okay. First, let's talk about how to calculate the slope of a line when you're given two coordinates, okay? And the formula is y2 minus y1 over x2 minus x1. I used to have it as y1 minus y2 over x1 minus x2, and people get so mad, so I changed it, but they're exact same. Bottom line is you're subtracting the y value of one coordinate from another divided by the difference of the x values. Just go in the same order, whatever it is, right? So subtract in the same order, okay? So we're going to give an example here, 7, 2, 5, 1. So the slope is going to be the difference of the y values. Notice how I stacked them and I'm subtracting down 2 minus 1 on top over 7 minus 5 on the bottom, which gives a slope of 1/2. Okay, give me 1 second. Just lay my dog out. Okay. Next, we have slope-intercept form for linear equation. Very important, very important formula. And that's y equals mx plus b, or we have slope is m. The y-intercept is your b. So if an example here, right? We have a slope of 2, a y-intercept of 7. What that looks like on a graph is it's intersecting the y-axis right there. It's 7. And the slope is 2, which is really 2 over 1, right? Any whole number is just over 1. Especially when we're talking about slope. That's how you want to think about it, which means we're going to get to the next point, up 2 and to the right by 1. Now, if it's negative, we'd be going down 2 to the right by 1, okay? So when it's negative, just one of those is flip-flop. Not both, just one. Next, we have point slope formula, which I used in one of the questions above. It's you take any point and slope, right? Here's our slope. And you do y minus the y value of the point equals the slope times x minus the x value of the point. So here's an example in point slope. And what can we say from this? We see that we have the point 3, 4, right? Again, it's x minus 3, y minus 4 means positive 3, positive 4. And we have a slope of 3 over 2, meaning, again, we're going up by 3 and to the right by 2. Or you can think about it as going down by 3 to the left by 2. Double negatives still turns out to be a positive, right? Okay, moving on to the midpoint formula. This is how you find the middle of any 2 points. Okay, and it kind of makes sense. It's logical. What are we doing? We're just taking the average of the x's, the average of the y's, adding them together, dividing by 2. And here's an example. 8, 4, 6, 7. We add 8 plus 6 divided by 2. That's 7. 4 plus 7 divided by 2. That's 5.5. That's how you find the midpoint. Boom, done. Distance formula. Somebody mentioned the distance formula. Here it is. The distance between any 2 coordinates. Okay. And we're taking the difference of the x values, squaring it, plus the difference of the y values, squaring it. And then we're taking the square root of all of that. And you might recognize this because this is actually a reformation of Pythagorean Theorem. Just FYI. You don't have to worry about that so much. I'm just telling you that. But that's what it is. Now, if we take an example, 5, 3, 1, 0, let's apply it. Plug and chug. Notice we do the difference of the x's first, difference of the y second. 5 minus 1 is 4, squared is 16. 3 minus 0 is 3, squared is 9. 9 plus 16 is 25, and the square root of 25 is, of course, 5. Now we have length of an arc of a circle. Here's the formula where n is the central angle, and we're dividing that by 360 because there's 360 degrees if you go all the way around. Makes sense. Times 2 pi r. 2 pi r might look familiar because that is circumference. And again, arc, we're taking a fraction or a piece of the circumference, just like the crust of a pizza. Next, we have area of a sector. Similar formula, right? It's going to look similar. Again, we're taking that central angle n over 360. And now we're not multiplying it by circumference, we're multiplying it by area of a circle, pi r squared, because now we're taking a piece of the pizza, full slice. All right. And by the way, this is in degrees. If you're doing it in radians for whatever reason, probably won't on the SAT, then instead of dividing by 360, you're dividing by 2 pi because, as I already mentioned, you can see on the reference sheet, 2 pi is equivalent to 360 degrees. All right, give me 5 more seconds. Moving on. Now we have the quadratic formula. Very, 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 very important. This one is how you can solve a quadratic if you got a quadratic equation, especially if you can't factor. And the quadratic formula is as follows: negative b plus or minus the square root of b squared minus 4ac all over 2a. I have a great song for you if you haven't checked it out on YouTube. Now, this is what you get in the Scalar Learning Dan Lerman super class. Ready? We're going to do a little acapella, see if I can remember it. My voice is a little raspy. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there you go. So you put that in your memory banks if that helps. But again, I have a music video on the channel if you need to check that out. Okay, moving on. Oh yeah, by the way, this is where does a, b, and c come from? It comes from the standard form of a quadratic. So if you got it in standard form, plug and chug, you got your x value. And it's really, what are you solving for? You're solving for your x-intercepts. Yes, and then Rue asks, what about arc length equals radius? Theta in degrees. Oh, if you're talking about arc length equaling that, this is so basically what you're talking about is that's what if it's in radians, right? Because think about it. You'd have your central angle in radians over 2 pi, and then the 2 pi cancels out with that 2 pi. So it's basically radius times the central angle is what you're getting at. But I think you're probably almost certainly going to get this in degrees. So think about it with the 300. Just think about this formula. Keep it simple is what I would say. Okay. Moving on to Formula 9. This is SOHCAHTOA for trigonometry. Gots to know this one. It's a must. Okay. So SOHCAHTOA, sine is equal to opposite over hypotenuse, stands for cosine is equal to adjacent over hypotenuse. Again, that's the length of the adjacent side over the hypotenuse length. Tangent is equal to the opposite over adjacent. Again, it's all relative to the angle in question, right? Here we're talking about angle A, hence the color coding, right? Opposite over adjacent. Opposite and adjacent refer to legs, can't be the hypotenuse. And then hypotenuse is a hypotenuse. That's it. Next, we come to probability. This one might seem a little straightforward, but it's still beneficial nonetheless. Number of favorable outcomes over the total number of outcomes. It's how many ways to win over the total outcomes. So if I say, what's the probability of me rolling 2 dice and getting, say, rolling 1 dice and getting an odd number? Well, there's 3 odd numbers on the dice, 1, 3, 5. So that's 3 ways to win out of a total of 6 options, 1, 2, 3, 4, 5, 6. So my probability would be 3 out of 6 or 1/2. Circle equaciones, which I showed you guys in one of those DESMOS hack problems, but here it is, right? And we've got x minus h squared plus y minus k squared equals r squared, where h and k represent the center of the circle, and we've got r representing the length of the radius. And again, you're squaring it in the equation. So here's an example where we'd have a center of 2, -5, and a radius of the square root of 36, which is 6. Okay. I have a song for this one too. Let's see if I can remember it. My voice is really jacked right now. 1, 2, 4. X minus h squared plus y minus k squared equals r squared. Okay, so there you go. And you can check that again on the YouTube channel. Will there be hyperbola and ellipse too? Highly unlikely. Ellipse maybe, but it's technically not supposed to be on the SAT. ACT, yes. But I would say almost certainly no hyperbola. And was there ever an ellipse problem? I'm trying to think of every single digital SAT practice problem, but I don't think I've seen one. Exponential growth. Okay, initial value. R is the growth rate in decimal format. So if it's 5%, it'd be 0.05, and T is, of course, time. So we're going to talk about exponential growth. Here would be an example. You got 200 whatever, right? It could be dollars. You're growing by 13% per year in 3 years. Plug and chug. Okay, you see the 13% is at 0.13. Likewise, if we have decay, right, we're shrinking. We're getting smaller. The decay formula, it's the same thing. Initial value 150, still 0.09, but now we're minusing. The other way to think about it is if you remove 9% every year, what are you retained with? You're retaining 81%. So that's another way to think about it. Hey, I'm taking away 9%, I got 81% left, etc. The vertex of a parabola, I cannot tell you how important this formula is. It's becoming more important, in my opinion, on the digital SAT. And we're going to show you in different practice problems like why it's so important. But just remember this. The x value of the vertex is at negative b over 2a. And that's taken from this standard equation, right? Y equals ax squared plus bx plus c. So it's a nice shortcut, but it also is going to be very useful for some of these very complex quadratic problems. Okay. Next, we have vertex form of a parabola. Here's our standard form. Vertex form is like this. So if it's in vertex form, if it's written like this, you know it's in vertex form. And the cool thing about vertex form is I can know what the vertex is, which is h comma k. Okay. Again, it's 8x minus h. So if it is x minus 4, the vertex would be at positive 4 for the x value. Next, we have for 15, which is the Pythagorean Theorem. But by the way, this is on the reference sheet. So I made one exception here to include something that is on the sheet. Actually, I think I made a couple other exceptions just because they're so important. But I would recommend memorizing this and knowing it. It's not super complicated to memorize. And how does it work? A and B are the two legs. They can be interchangeable. It doesn't mean that B has to be the longer leg. It doesn't matter. A and B are the legs, and C is the hypotenuse, and that's it. A squared plus B squared equals C squared. Boom, done. Okay. Yeah, special right triangles. This is also on the formula sheet, but I thought to include it because I wanted to explain it. We have two special right triangles that are important, 45, 45, 90. And where the legs, if those are both going to be equal, as they will be for 45, 45, 90, the hypotenuse can be found by taking that and multiplying it by rad 2. For 30, 60, 90, whatever the smallest side is, which is our leg is, which is opposite 30, the longer leg is that smaller side times rad 3, and the hypotenuse is double the little dog. Okay, so it's a 30, 60, 90. Those are the relationships. And this is just a formula overview. Once we get into the weeds with the critical concepts and start doing practice problems, you're going to see how to use all of these, and it's going to make a lot more sense. This is just an overview right now. All right. Next, we have distance equals rate times time. You might say this is a really simple equation, d equals rt, but it's very useful, okay? Distance equals rate times time for some of these rate problems. And just having this as a foundational piece that you can go to. It's like, oh, it's a rate problem. I know I need this. It gives you a really good scaffolding to start your work. I think it's highly underrated. Next, we have sine and cosine, but we already talked about trigonometry and we already talked about SOHCAHTOA. This isn't about sine and cosine in particular. Oh, somebody's asking, is this useful for the PSAT? Absolutely. Math on the PSAT is equivalent. Anyways, sine and cosine. This is about special relationships between sine and cosine, which is sine of an angle equals cosine of the complement of that angle and vice versa. So what does that mean? Sine of 10 equals cosine of 80. Sine of 20 equals cosine of 70 because 20 and 70 are complementary, meaning they add up to 90, and so on and so forth. We have all these relationships and infinite other ones. This was a relationship that was tested a lot on the paper version of the SAT. I see it tested less on the digital version. I don't know why, but I want to include it just in case it does creep up. Now we're moving on to sum of solutions for a quadratic in particular, okay? So let's say we have this equation and we say, hey, what are the sum of the solutions? Now you can find the two solutions, use a quadratic formula, factor, whatever, or you can use this amazing shortcut, which is the sum of solutions of any quadratic is negative b over a. In this example, the sum of solutions for this quadratic would be negative 7 over 2. Done. Right? Way less work if you can pull that off. What about the product of solutions of a quadratic? Same equation, but the product of solutions is a little different. It's not negative b over a. It's positive c over a. This is now being used. It wasn't used on the old SAT. Now I've seen it creep up. So make sure you remember this. Saves you a ton of time. Otherwise, you have to find the two solutions and multiply them. That's much longer process, especially if you have weird solutions with radicals and all that stuff. Much easier here. In this case, the product of solutions would be negative 5 over 2. Boom, done. Now we're talking about the discriminant. Again, for quadratics, very, very valuable formula. And the discriminant is b squared minus 4ac. When are you going to use this? When we're talking about number of solutions. So they say, hey, how many solutions does this one have? Well, You plug in the value, calculate the discriminant. We get a negative value, 9 minus, what is that, 40, negative 31. Since it's negative, you get no real solution. Likewise, if they say we have a quadratic with no real solution, you know the discriminant must be negative. Okay, so it goes both ways. Now, if we say, all right, here's another equation, and my discriminant is equal to 0, that means we have one real solution. Conversely, if they said, hey, you've got one real solution, now you know the discriminant must equal 0, which might help you solve for a missing value, which happens all the time. Last but not least, we get a discriminant that's greater than 0, right? In this case, whatever it is, 36 minus or plus 84. So what is that, 110, right? Or 120? And 120 is positive. That means you get two real solutions. Nature of solutions, that's what the discriminant is all about. Area of an equilateral triangle. Is this the most important formula in the world? No. Does it come up sometimes? Yeah, maybe, occasionally. So I wouldn't drive yourself crazy over trying to memorize this, but it's a nice one to have in your back pocket, and it's simply s squared times the square root of 3 over 4. So a couple examples. S is the side length, right? Equilateral, all the sides are the same. So this is just 1 times rad 3 over 4. This would be 4 times rad 3 over 4, right? 2 squared is 4. And for 3, it'd be 9 rad 3 over 4. That's it. Pythagorean triples. These are not exactly formulas, but these are relationships that if you memorize these 4, it's a little shortcut. End of the world if you forget them? No, because you can always use Pythagorean's theorem and figure out the remaining values. But it's nice. If you see a 3 and a 4 as 2 of the legs, you know the hypotenuse is 5. You see a 24 and a 25 for one of the legs and the hypotenuse, you know the other side is 7. And these are the 4 most important ones, pretty much the only ones you'll ever get tested on the SAT, as well as their multiples. So 3, 4, 5 can also be doubled, tripled, quadrupled. Same for the rest of these guys. So these are the ones, again, you don't have to have it fully memorized, but just be mindful. 3, 4, 5 is the most important. If you're going to do just 2, 3, 4, 5, 5, 12, 13. But these are the ones that you can expect to potentially see. Okay. Next, we've got perpendicular slope. By the way, parallel slope, I didn't include it here. Maybe I should have, but parallel slope means the slope are equivalent, the same. One has slope of 2/3, another one has slope of 2/3. They're parallel, assuming they have different y-intercepts. So that's not as hard to forget, but perpendicular slope a little bit tougher. And what we have is opposite reciprocals, okay? So if we have a over b, negative b over a is perpendicular. With concrete examples, 2/3, opposite reciprocal is negative 3 over 2. These would be two perpendicular lines. Next, we get to sum of angles in a triangle, again on the reference sheet, but it is 180 degrees. But what about for other shapes, other polygons? We got this amazing formula. So if I have a polygon and it has 4 sides, you're going to plug in 4 for n, and you're going to get the value. So let me give you some examples. So n is the number of sides of the polygon. Triangle, I already mentioned 180. What about a quadrilateral? Rectangle, doesn't matter, 4 sides. 4 minus 2 times 180 is 360, and a pentagon is going to give you 540, and so on and so forth. You could do this for a decagon, a dodecagon, whatever shape you want. 26, rational functions. This is now making an appearance. It wasn't there really before. What is a rational function? It's literally a kind of like a function divided by another function, okay? It's like 2 linears stacked on top of each other. Here's another example, x plus 2 over x minus 5. So little quick facts to know about rational functions, okay? They kind of look like this, and that x minus 4 in red represents my x-intercept, okay, where it zeroes out the function value. And what zeroes out the denominator is going to be a vertical asymptote. And that makes sense because negative 3 is where you're going to be dividing by 0. Negative 3 plus 3 is 0. Hence, it gives you that vertical asymptote, meaning no man's land, all right? In this other example, in f of x, the second one, oh, by the way, sorry, y-intercept, you just plug in 0 for x, and that's how I got negative 4/3, right? So it's just negative 4 over 3. For this other one, we have an x-intercept occurring at negative 2, okay? We have a vertical asymptote at x equals 5, and then again, we have a y-intercept at negative 2/5, right? Just that 2 over negative 5 if you zero out the x. 27, I'm starting to lose my voice. We're getting close to the end here. 34 formulas. Excuse me. Triangle congruence. You got to know the theorems for triangle congruence, and there's only 5. You might remember this from geometry. We have side, 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 meaning all the sides are congruent. You know that the triangles are congruent, meaning all the angles are the same. That's what congruent means. Everything is the same, angles and corresponding sides. If you can show that one side, one angle, and then the next side are all congruent in a row like this with the angle between the two congruent sides, they're congruent. Everything's equal. Angle, side, angle, same thing. Angle, angle, side. And last but not least, if you know they're two right triangles, if we have a hypotenuse and a leg, either of the legs, hypotenuse, leg, the whole triangles are exactly equivalent. Done. Okay. Next, we have triangle similarity, and this is popping up a lot as well. There's only 3 theorems for triangle similarity. First is angle, angle, most commonly tested. You show 2 angles and any 2 triangles are equivalent. They're similar, meaning they're proportionate. Okay. Next, we have side, angle, side, meaning if I have like AB is proportionate to XY in the same way that AC is proportionate to XZ, and the angles in the middle, meaning X and A, are equal, we have side, angle, side similarity. Last but not least, we have side, side, side similarity. Not meaning all the sides are equal, but meaning all the sides are proportionate in the same way. They all form in the same proportion. Okay, 29. Unit circle. Now again, I mentioned before, do you have to know the unit circle? No, but if you know it, it's nice, okay? So I want to give you that out because I know some people have a tremendously difficult time memorizing the unit circle, but let me talk about it and let me give you some tips on how to memorize it. If you still can't, don't sweat it. There's ways around it. Here's my unit circle, okay? And the thing about the unit circle that you might want to remember, and the most important thing is just really knowing the first quadrant, and then you can kind of apply that pattern throughout. But you really only have 3 unique values: rad 3 over 2, 1/2, and rad 2 over 2. I mean, obviously you have 1 and 0, but those are more obvious, right? So look at the progression: rad 3 over 2, 1/2, rad 2 over rad 2, and then the next one is those ones flipped: 1/2 rad 3 over 2, and then they keep repeating in some order. But you know that on all the quarters, it's always rad 2 over 2, rad 2 over 2, just negative, rad 2 over 2, rad 2 over 2. So anyways, you can start to map this out. Now, what are some other things to remember? Sine of an angle. So if I'm like, hey, what is sine of 60? In the unit circle, it's the y value, rad 3 over 2. What is cosine of an angle? It's the x value. What is cosine of 120? Negative 1/2. And what is tangent? It's the ratio of y over x. So what is tangent of 45? It's this over this. It would be 1. Let me give you some examples. Sine of 45, the y value there, rad 2 over 2. Cosine of 150, negative rad 3 over 2, right? And again, it's the x value. And tangent of 240 down here. And it's again the ratio of negative rad 3 over 2 over negative 1/2 right there. Okay. 30, foiling. Remember how to foil when you're multiplying 2 binomials. Actually, even you could do larger distributions as well, but foiling, the acronym specifically refers to a binomial times a binomial. Hold on, I'm just opening the door for a dog. So foiling, what does it stand for? It stands for first, which are the first 2 terms multiplying, outer, which are the outer terms multiplying, inner, which are those 2 inner terms multiplying, and last, the last 2 terms multiplying. And then we're going to add all those up. So let's write it out. First, we got the first, x squared, x times x. Then we got the outer, negative 6 times x, which is negative 6x. Then we got the inner, 3x. And then we got the last, 3 times negative 6, negative 18. Here we got 2 like terms, so we're going to add those together. And we got x squared minus 3x minus 18. That's how you FOIL 2 binomials. What about squaring a binomial? Cool. X plus 3 squared, so it should just be x squared plus 9, right? Wrong. This is a mistake. This is a trap. This is not how you square a binomial. In fact, you're going to have to actually FOIL it. It's itself times binomial times itself. So we go back to foiling. Boom. First, x squared. Outer, 3x. Inner, 3x. And last, 9. Add those 2 middle terms together. And that's how you do it. That's how you square a binomial. 32, we got a lot of rules here. These are exponent rules. Tons of rules within this formula, quote unquote. It's like many formulas. When you multiply two variables, what are you doing with those exponents if they're the same variables? You add the exponents. What about when you take this to raise it to a power? Now you're multiplying the exponents. When you're dividing with the same base, you're subtracting the exponents. A negative exponent means 1 over, right? X to the negative 4 is 1 over x to the 4th, and so on. Anything to the 0th power is 1. That's a beautiful one to remember. Anything to the first power is just itself. And when we have a fractional exponent, the top number is the power and the bottom number is the index of the root. Okay, so it's the nth root of x to the m. Or you could say the nth root of x and that whole thing to the mth power. I mean, you could do it either way. So let's give some concrete examples. This should be 2 to the 5th, right? We're adding the exponents. And 2 to the 5th is 32. This should be 2 to the 6th because we're multiplying those exponents. That's, of course, 64. This we're subtracting, so it should be 4 squared, which is 16. Here we're doing 1 over 5 to the 3rd, which is 1 over 125. So anything to the 0th power, as I mentioned, is 1. Anything to the first power is just itself. And to the 2/3, this means the 8 squared and the cube root of that, or the cube root of 8 squared, either way. And this way we get 64, and the cube root of 64 is 4. Or cube root of 8, which is 2 squared, is 4. You can do it both ways. All right. Hey, somebody said first lesson is absolutely fire. I love it. Thank you. Oh, that is so great to hear. Put a lot of time and effort into planning this out, so I really appreciate that. 33, let's get into absolute value, okay? So this is how you solve any absolute value equation. Split it, or bifurcate, as I like to say. And we split it into x minus 4 equals 6, and as well as x minus 4 equals negative 6. And then we just solve for x. Add 4. And add 4. And we get our two solutions, 10 and negative 2. You can plug them in and double check, but 10 minus 4 is, of course, 6. Absolute value of 6 is 6. Negative 2 minus 4 is negative 6. Absolute value of negative 6 is 6, because absolute value is the positive purifier. Boom, done. Last one, inequalities, and this is a good little rule to remember as we're isolating. Okay, we add 4 to both sides. Negative 3x is less than 9. Divide by negative 3. And then we got x is greater than negative 3. What did I do? I flipped that inequality. Why? Because whenever you divide or multiply both sides by a negative in an inequality, you must flip that inequality. Very important rule. They will get you on that. So make sure you remember that. Make sure you remember this guy, dude, with the sign. And that's it. We are done, ladies and gentlemen, with day 1. Okay, first lesson is completed. Again, for those of you guys who stayed to the end, legends. Much appreciated. Thank you so much for everything. And if you haven't liked the video, make sure to click that like button. Now, as I mentioned at the beginning, we're going to be back next week. I'm going to post the homework assignments, things I want you guys to do tomorrow, Thursday, and Friday. You already know what's on Saturday. Saturday, you're taking practice test 1. Leave all your questions in the Skool page. If you haven't joined our Discord community, you can do that as well. You can also message me there, post questions there. But I would recommend joining the Skool community if you want to follow along with our class. We're gearing you up for this August SAT, guys. So make sure to join along with us, give you some amazing structure. And I want to see how you guys perform. I think you guys are going to do absolutely amazingly. We've got Kakashi said, hey, L-Flash says, thanks. Have a good day. You are welcome, my friend. You too. Got a 760 last time, aiming for 800 this time. Thank you so much. You're very welcome, and I love that. 800. Kalsum Wali, thank you so much. You're very welcome. All right, guys, my voice is about to go bye-bye, so I'm going to sign off. But, hey, like I said, you're a part of history. This is our first class, and we are so excited to be providing this to you and giving this away for free. So thank you guys so much. And